OSI model, it is designed to solve a major problem, interoperability, and then to make sure that multi-vendors devices are interpretable. In other words, they should be able to function in an environment where we have different vendors, different standalone vendors. For example, most of the environments, we have different vendors. Some environments have more than 10 devices. So, and then they need to communicate. Before this model was developed, it wasn't like that before. It was a standalone issue. That is, if you have IBM, it will mean that everything, every network in your every devices in your network will be IBM devices. From router, switches, all the PC, they will be IBM. If you have anything like Unisystem, it will be majorly based on this. So when this concept or this model was designed, it solved the problem. That is, the devices now communicate, whether they are from the same vendor or from different vendors. And then this, from ear to ear, they are just the theories behind it. So if you look at it, you see that it provides a common basis for coordination of standards and development of the purpose of system interconnection. The keyword here is interconnection. That is, the OSI model facilitates interconnections of devices. And then if you look at it, all these are just part of the literature behind it. That is funded by US departments, that is DOD, and then this is the year that it was published to the public. And then there are requests for comments. If you want to read more about it, this request of comment is the link we will follow to read most of the update or some additional features on this OSI model. I have a link that was sent to us after this conversation so that we can read more about it. It is not what we can just memorize. We need to be reading it over and over. If we want to go extra layer, we can even take the picture, place it somewhere you can be seeing it at a regular interval. So OSI model is open systems interconnection, and it has 7 layers. From the left, okay, now let me use one image to depict this interconnectivity. Okay, let me go to my screenshot. Okay, I believe we can all see the screen. All right. Okay, let me use this one. This one. So this is how I want to explain it so that we can get full understanding of the OSI model. It's very complicated, but it's very easy to understand. And then once we understand it, every other thing will follow. Every other concept we'll be talking about it will be the foundation. So let's pay attention to it. And then after this class, we should try to read more on our own. Okay. So as the name implies, the OSI model, open systems interconnection, it facilitates encapsulation and de-encapsulation. So now, we as network security engineer, this is our scope. This is where we work. From layer 4 down to layer 1, this is our scope. All this layer from session layer, presentation layer, application layer is for developers. So we pay more attention to from layer 1 to layer 4. And then when we find ourselves in an environment where, some environment are very chaotic, when we have like P1, P2 tickets, this relates to layer 1, layer 2, or layer 3 at most of the time. I cannot connect, or I don't have access, or I can't log in, or VPN issue. Those are the area we treat it. So in the past, the older model, they were proprietary in nature. Like I said before, they could not connect. And there is control. They could not connect to other vendors' devices. And they were controlled majorly by the vendors. But after the OSI model was published, developed, it became a standard-based model. It's a standard base. And then if you look at it, most of us who are working now, we see that no time in the workplace will anybody reference OSI model here and there. So it is not a physical model. It is a reference model. Most of the time it's for conversational. It is for conversation between the professionals. Oh, it is layer 1 issue, it's a layer 2 issue, it's a layer 3 issues. So we will just need to familiarize ourselves with those jargons. So if you look at it from on my left-hand side, we have PC1 and a PC2. So anytime this PC is trying to connect to anything, either through LAN to WAN or from LAN to LAN, regardless of the communication, they will pass through this 7 process. This will represent our clients. This will be our server, for example. So anytime this PC make a request or initiate a request, there will be an encapsulation from top layer of the OSI model. There will be what? Encapsulation, encap. There will be an encapsulation. So now, coming down from encapsulation to layer 1, and then going to the server, when it reaches this side of the server, on the layer 1 side of the server, it becomes the encapsulation. It becomes what? The encapsulation. So each layers, they have specific function or specific functionalities. It is not enough just to memorize or for me to just walk through 7 layers. This is what we do. No. These are the underlying theories behind them, what they do, why they are doing what they are doing. Unlike before or in the past, the PC1 of maybe we have Windows PC, and then we have Mac OS on the other side. They will not be able to communicate in the past. But after the OSI model was developed, the interoperability came into existence. So before we go into each layers, some people developed method where we can memorize all this, but to me, it is of no use. If what they say, all people sleeping through network don't pass. So application, presentation, session, transport, network, physical layer.
That is actually my favorite. I still use that today. That was actually developed by David Bomber. Sorry to interrupt.
Say that again. I didn't hear you. Can you say that again?
Okay, sorry. What you mentioned now, like all people sleeping through network, it don't pass. That is what I've memorized, and I use it all the time for years now. I think I've actually heard it for the first time from David Bomber. I heard it from David Bomber.
Yeah. That's okay. But you know, everybody has ways of knowing certain things, but you know, what I believe is once we start reading it over and over, we will get used to it. But if we can use that method again, like what the other brother said now, like the application, presentation, session, transport layer, and this and that, this is for all people, for P, sleeping, and through network don't pass. So if you can memorize this, fine. But over time, we get used to, we get used to it. But any method that we know we can formulate that will enhance our understanding of it, so be it. But one funny thing about it is, it is no matter the literature we read, it is the same all over. So nobody will ask us what is advantage of OSI model, all that, but I will just explain it a little bit. So advantage of OSI model is it creates a standard for the vendors, not for us, for the vendors. And it creates interoperability. And it makes it for vendors to have a quicker development of what? Of devices. Because they have a standard to follow. It's like our own blueprints in network. So that's why when you look at, okay, before I cancel this, we understand this side, the encapsulation and the encapsulation, because each layer performs a specific functionality. That is from the layer 7, which is application. When the application is requested from the PC1, this one we look at the application, you now encapsulate it, send it to the presentation, come down to the session. This session, I will talk much about it when we are talking about firewall and some other stuff, what we mean and how we use it. To the network, to the data link, and to the physical. Each of the layers, they perform different or specific functionality. And then anytime IT professionals, especially network and security engineers, are talking about layer 2, layer 3 devices, they are talking about, they are making reference to this model. And then there are some devices that are basically located at different layers of this model. We'll touch base about it. This OSI model is not difficult, but I don't know how to define it. That we just need to spend time to read it on our own. It's a beast on its own. One will need think, I know it very well, but when it's time for the interview, you know, oh, so I don't really know it as well. So we need to spend more time on it by studying it, by looking at it over time and watching other videos as well. So let's stay away from here. But any questions so far relating to this encapsulation and the encapsulation? All right, let me clean this one. I will go back to the notes.
I have a question.
All right.
Hello? Yeah, the encapsulation and decapsulation, is it similar to encryption and decryption?
No. Encapsulation is, we have headers. You understand what I mean by system headers or IP headers? Encapsulation means when this request is coming from the client, all these requests, they come with a lot of information. Like HTTP request, they have some headers attached to it, like MAC address, like IP address attached to the request. So let's know we have 1, 2, 3, 4, 5 now. This is our request. When it's coming from the PC1 going to PC2, these layers will be removing bit by bit until layer 1, where the packet will be sent on the bits. So removing of the headers, and covering of the headers, it is encapsulation in the OSI model format. It is covering the headers. It's not encrypting it for now. What it's doing, it is adding more layer. Okay, now let's use a very simple example. If we have a ARP request, this is too much for this class for now, but let's talk about it quickly. It will have MAC address header. To know where to send, to know the device, specific device that they will send this request to. They will attach the MAC address of the PC to the request. So now on the encapsulation format, it will be there. So on the other side, from the layer 1, the encapsulation will take place by removing some of the attached protocols. So before it go to layer 7. So encapsulation will take place from one side, the encapsulation will take place the rest. Because if it is encapsulation on both sides, the computer will not be able to read it. Because the computer should be able to read the underlying information by de-encapsulating it. I hope that answer your question.
Yes, yes.
All
Thank
right.
you.
No problem. So these are just theory relating to OSI model. But let's start from the bottom, from the top to bottom. We can start from bottom up, but most of the time, let's start from bottom up. Let us from layer 1 to layer 7. All right. So if we look at layer 1, which is the physical layer, we see that layer 1 is majorly, it converts the data bits into electrical format. So now, from the layer 1, what we talk majorly on layer 1 is what? Is the cabling. Cabling. Last week, we talked about RJ45. This is layer 1. And then we talk about interface. We talk about NIC, network interface card. These are the devices we will find. These are the items we find in layer 1. It's majorly for cabling. For example, now, if you have a layer 1 issue, it means the cabling is not properly plugged in, or the interfaces is not up. That's why when we are troubleshooting network, we need to check if the ports or the interface is up and running. We need to check that. This is one of the formats we need to quickly check. And then in the layer 1, like I said before, it converts bits into electrical signals, and then it is majorly for binary transmission. And then we all know that computer understands simple language of 0 or 1, or on or off. So this is the interface, this is the layer that deals with that. And there is majorly a physical link. It's majorly a physical link. So there are some other concepts relating to how the cabling, there's a lot of theory relating to that. But let's just focus on understanding these 7 layers, some of the protocols, some of the items we can find on them. Because it's true, only the layer 1 can take us a whole session if you want to deep dive on it. But important thing is, we just need to understand some of the functionalities, the most important functionalities each role plays. If you want to deep dive into it, it will take like forever. So layer 1 is majorly for cabling, and then we use RJ45 and some other cabling or interface method in layer 1, and then it is where the NIC is located, and then it's for what? It's majorly for binary transmission. Even in interview, okay, what is layer 1? What is happening in layer 1? Layer 1 is majorly for cabling. The interviewer will know that this person knows what he or she is talking about.
I'm in class.
So,
Wow.
let's move forward to layer 2. And then another thing we need to pay attention to quickly in layer 1 is the output of layer 1 is bits. The output of layer 1 is bit. If each layers, they have specific output. So we are in layer 1 now. We know that layer 1 has a bit. So when we move to layer 2, we talk what it has. So layer 1 is what? It's majorly for electric conversion or convert of bits into electrical signal.
Do everything together.
That is that. And
I'm
then
going to do
you
the
look at
next
this.
Friday, a long
Let this
Friday.
bomb meet himself, please.
Much the February. Oh, I send the card for $20. You only be share online.
Mute. You need to mute yourself. You are not muted.
Okay. So, that is on layer one. So any question related to that? This one, I just put this note here for half duplex and full duplex. Most of the devices in this our own generation now, it is majorly full duplex, not half duplex. What is half duplex? Some of the folks who have played around with walkie-talkie before, back in the days, when somebody where we have this kind of small device where A say hello to B. B will wait to hear the hello before B can reply I. This is half duplex. It means only one device can talk at a point. Both of them cannot talk synchronized in a synchronized way. That is, when A is talking, B will pause. When B is talking, and then A will pause. That is half duplex. But most of the devices in the industry now, they are full duplex, meaning both devices can communicate simultaneously. Both of them can initiate requests, they can talk, they can exchange data simultaneously. That is half duplex definition and the full duplex definition. All right, so let's move to data link. Data link is layer 2 in the OSI model. And then what it does, it provides node-to-node data transfer. And then in the layer 2, we have output called frame. The output of layer 2 is frame, because in layer 2, we have a device called switch. And then we have address in layer 2 called MAC address. We talk about this MAC address when I was talking about NIC in the first session. That is, network interface card has a physical address attached to it. That address is called MAC address. This MAC address, it is physical to the device because it is engraved or soldered to the motherboard, majorly for identification of the device and the vendor. So on this side, we have a device called switch. This switch, we'll go deeper into it later, how it's been configured, how we can initiate it to the network, where it can be added, type of switch we have in the industry, and then who are the major supplier, who are the major company that have the largest share in the industry. We'll talk about those one as we move on. But we should not forget that layer 2 in the OSI model is data link layer, and it is majorly for node-to-node data transfer, and then the device in that layer is switch. When we are talking about layer 2 issue, everybody, all the engineers should know that it is switch issue. Those are the basic things we can introduce or we need to be speaking about during the interview. So the interviewer will expect us to know that. They want to hear from us what is layer 2 devices, what are the things it does, and then how to manage it, and also and so forth. So different literature says so much about it, but we just need to pay attention to the functionality and then some of the devices they walk around with. When we talk about, later we'll talk about another model, but this one, let's cover this one first. But another thing I would love to emphasize is this is a reference model. It is not a physical item. It is reference. And then if you look up here, they say 7 different abstraction layers. The word abstract is virtual. It's not physical. So it's not what we can see. It is just for reference. So that's layer 2. On the layer 3, quickly, this area, which is layer 3, it is area where we work most of the time. That's where we specialize as network engineer, as a security engineer, because most of the time we are the one configuring or input some of this configuration into devices. So if you look at this is area, this layer is called data delivery layer. Data delivery layer. Because this is the layer that facilitates what? Routing forward decision making of forwarding a packet. It is made by network layer. That is why the output of layer 3 is called packets. And then what's the packet? A packet is what? It is breaking down of chunks into what? Into formats that can be handled by a computer. It's breaking down of what? Breaking down of these chunks to what? To manageable or segmentation that can be managed by a computer. So in layer 3, we have packets. So most of the time, with it's missing packets. We have a lot of packets. So, and the device in this layer is what? It is router. Many of us know about router. Some of us that don't know about router, we know it. And then we deep dive on router later. Not only router we have at this layer, we have what they call layer 3 switch. Layer 3 switch. This layer 3 switch, we talk based, when we're talking about switch, we touch base more on it. We go about 400 level deep dive on some of the devices. So layer 3 switch, as the name implies, is a switch that have the 2 capabilities, one for layer 2 and the one for layer 3, because it has routing capability. So we have some protocols in layer 3 that facilitate routing forwarding, because like we said network layer, it is for what? It's for data delivery, and then it routes data packets from hand to hand or from one device to another device, and then it helps devices, that's layer 3, to select the best path to deliver data. That's why when they were looking after this, because I'm checking time as well. After this session, we'll take a look at some of the job description. Most of the time, we always see this OSI model there, because they want somebody who has granular experience on OSI model. So if we can spend more time on it on our own, it will be better. You cannot just listen to the video, listen to me right now, I think it's done. No, we need to listen to the video again and again and read a lot of literature online, because this is just a summary of large documentation. So now on the layer 3, that is network layer on OSI model, we said it has some protocols that facilitate delivery of the packets or data delivery. If you look at the under the network layer, that's a network layer, we have IP, we have IPsec, we have ICMP, we have IGMP, OSPF, and RIP. All this will be talked later, what they do, how they function, and all that. And then on layer 3, it is packets. Now we have 3 items now. It may be a new word to some of us. We have bits on layer 1, we have frame on layer 2, and then on layer 3, we have what? We have packets. So layer 3 transfer packet from one node to another connected in different network to another what? Connected. This is example. We have one PC here. We have another PC here. Now we have a router connecting to this router. The PC, the other PC on the right connected to this router. That is PC A and PC B. This router facilitates data delivery. And then most of the time, when we have issue on the network, this bad guy is the major guy we always blame. Oh, it is router issue. Because without a route, the device will not know where to forward the packet to. It will become undeliverable, unreachable, or timeout. When we go to the lab, we test some of those functionality, but we just need to know that the device in layer 3, it is called router or layer 3, but the majority of it is router. So if we find ourselves in an interview, tell me about the OSI model, we should come from either from top to bottom or from bottom to top to bottom or from bottom up, any which way that works fine for us. And then when we are defining OSI model, especially during interview, because this is majorly designed for interview, it has nothing to do with working. It's good for working, just for conversation. And it's good to be handy, to have it handy to ourselves when working too. If we find ourselves when we need to configure switches, routers, we know that, oh, when we're talking to the stakeholders or the clients, oh, it's a layer 2 issue, we're going to handle it. So you just need to throw them off balance. Or the stakeholder will be asking what is layer 2 before they ask the question, we are moving to the next stage. So that is layer 3 for us. And then we have OSPF, BGP, ISIS, and some other protocol that we're going to discuss deeper on as we move forward. That is layer 3. So let me talk about layer 4 before I give room for questions. And then, like I said before, from layer 7 to layer 5, it is not our concern most of the time because it's deal with data. But I'll touch base a little bit about them, and then I will send this note to the group so that we can just keep it handy. It's good for interviews, and it's good to know too. So that is layer 3. let's move on to layer 4. Layer 4, this layer is very, very good to know. It's very good to understand it deeply because it deals with some protocols that we always talk about. A lot of people, a lot of interviews, they will be asking some of the layer 4 protocols. What is TCP? What is UDP? Tell me about it. So we need to read more about it, and I'll touch base on it now. So on OSI model, layer 4, what it does is it does end-to-end connections. End-to-end connection, and then breaking large protocol data units or long data stream into smaller chunk called segments. This is what I was referring to before. This segment will be again break down to packets into layer 3 to be able to process it. They have different headers. That's when we are talking about encapsulations and the encapsulation. Each header will be, each layer has format they will encapsulate as moving from the stack. So on layer 4, we said it is end-to-end connection. It is for message segmentation. The message segmentation comes to what? Breaking down of those large protocols. And most of the time, what if you forget everything on layer 4, what we need to remember is these two items, TCP and UDP. As I'm talking about this OSI model, I don't expect us to memorize everything, but there are some items we need to remember. If we need to memorize it now, we need to later or today anyhow. We just need to know it. We need to know that TCP is in layer 4. Router is in layer 3. Switch is in layer 2. And then the bit signal is in layer 1. We need to pay attention to that. We need to know that. So apart from the literature part of it, if you look at it, we say transport protocol may be connected oriented, which is TCP, or connectionless, which is UDP. In layer 4, what layer 4 does is it ensures that data transport is either reliable or not reliable. It ensures that it selects the best protocol for that stream. It selects the best protocol for that stream. Each protocol, they function on a different radar, because as we are speaking now on this Zoom meeting, we are using UDP. Because the example of UDP is, I'm just talking from my ear, from my house here. I don't know maybe you are hearing me or not. I keep talking. So along the line, there are some packets that may be lost, or there will be a latency, there will be a jitter that cannot be verified by me right now. But UDP doesn't care whether you hear or you don't hear, it will be sending the stream. Most of us who are always on Instagram, those are the UDP protocols. They function behind the scene to make sure that videos, streaming, voice message, they are delivered. There are some packets that may be lost, but it is what it is. That's how that protocol functions. But when it comes to TCP, TCP is connection oriented. It means every time there's a packet or error, there will be a retransmission. That's why if we look at it, we say segmentation and reassemble of segments. That is functionality of TCP. TCP will ensure that the packet is delivered accurately. It has some error correction capability. So everything I say here, if you forget everything, we should not forget that on layer 4, two protocols are dominant. which is TCP and UDP in layer 4. And then one is connection oriented, the other one is not. So later we'll talk about difference between TCP and UDP when we're talking about three-way handshake and all that. We'll touch base about that one later. So TCP is transmission control protocol, that is TCP, and then UDP is what? User datagram protocol. And then of recent, there's another protocol introduced. It is common in the network now. It is called QUIC. I've read about it, and then it is very fast, very reliable, and some organizations are blocking it. They don't want it in their network, but as time goes by, this QUIC will become a common protocol like UDP and TCP, because according to the article I read, QUIC was developed on UDP by Google. So on top of UDP, they make some configuration to use TCP functionality. So now on every QUIC transmission, there will be a UDP header carrying TCP format. So in the near future, there may be TCP will become obsolete. QUIC will now become the ad hoc protocol. So that is layer 4 for us, and then what it does, and then we've talked about TCP, UDP, and then message segmentation. All these are just story, but the important thing is to pay attention to those protocol in each layer. So if you look at here, we have MTU, maximum transmission unit. When we are talking about segmentation, there are some there's number of packets that can be sent, or segment that can be sent from one device to another device. That is called MTU, maximum transmission unit. The maximum is 1,500 by default to most of the devices. 1,500 bits or bytes. 1,500 bytes. So anything exceed this we call jumbo bytes. Jumbo bytes. Some interview, they ask this question, but just theory based. So we always configure our interface to listen on either this or 14,060. It can be manipulated on the interface level, but by default, this is the maximum transmission unit byte. So that is that. And then on layer 4, the output is what? Segments. Like we said before, we have bits. Yeah, bit in layer 1, frame, layer 2, and then layer 3, we have packets, and layer 4, we have segments. Segment is segmentation and assembly of segment, where the the large chunk of data were segmented. So that is that. And then if we move on to layers 5, 6, 7, quickly, layer 5, we'll talk about it when we're doing firewall, because it is for data, it's just to keep the session. When two devices are communicating, as we are communicating now, it's called a session. As you can hear me now, it's called a session. So we can use it to analyze our log, to see what transfer or what goes across our network. So there will be a session. So that is what layer 5 does. It keeps the session. That is, every time we log into our computer and we log out, this is session layer that keeps all the information. It establishes the session between two nodes. create setup, control connections, and hence the teardown between two or more computers. So it is a session layer. So that one is very easy for us to understand. We don't need to memorize it. We just need to know that when two computers connects, there's a session established immediately. That is the functionality of layer 5 by making sure that that session is established. And then when when the conversation ends, it closes the session gracefully. So we will not talk much about, we will not talk more about that. Apart from that, that's the functionality of layer 5. And the presentation layer, this one, it is a syntax layer. Computer listening to different formats. So this is the layer that converts those formats to the interpretable format for the computer, because we have different scripts. So if you will look at it, it handles protocol conversion. It will, for example, now, different devices want to communicate. Maybe we have a Mac here, we have a window. So the presentation layer will now present the format to the computers, because after presentation layer, we have application layer. So it will present to the computer in a format that can be readable by the application layer. So if you look at here, this is a layer where data encryption occurs, data decryption occurs. So if you forget everything, we should not forget that it's a syntax layer where data formatting and translation occur. All right, application layer. Application layer is the layer that all of us are used to. We all know that. Anytime we open our WhatsApp application, that is application layer. Anytime we go to web browser to search for Google, search on Google, that's the application layer, because it is close to the end users. It is what the end user understands. For example, now, if somebody in an organization maybe is working in he or she's working in the marketing department. Oh, I cannot go to marketing.com. What's going on? So what she knows that, or he or she knows, is she couldn't go to marketing.com, but there are some underlying problems behind that not be able to go to marketing.com. So the only application should be seen is the web browser. All these protocols, these are the protocols that works in application layer. We don't need to memorize them. As we move on, we understand each and every one of them, what the functionalities are, what they do, how they behave. Their patterns will be discussed. But what we need to understand majorly is the application layer is the layer that is closer to the users, and then most of the protocols that functions in application layers are these. DNS is there as well. DNS is an application layer. SSH, these are the application layer, because they are application based on the fact that these are the interface between the applications and the users. So any question or questions? This is where we're going to call it a day. I know it's very long, but this is how it always is, because this topic, it's very simple if we can read it over and over, but it is not what you can just say, let me memorize it once and it is done. No, we need to visit it over and over, and then if we can develop method to memorize it, so be it. But what is the importance for us now? The importance is to be the gate man. That is majorly using in the interview. And it is majorly using what? in conversation. That's why when we look at here, I wrote it somewhere here. Where is it? See, I wrote it here. Standard model for discussion, discussing, and teaching. Standard model for discussing and teaching networking in the field of information technology. So this is the most important. If you look at here, discussion and the word teaching, it doesn't have any more reference than that. And it's a reference model, like the way architects have their own blueprint when they're designing houses. They have some format they follow. That's also, we have our own formats. So if you look at this, that's why we should spend our time reading good literature. Some people will just take only this one, read only, nothing we can decode from here. Nothing. If we only get this picture and then memorize it, this is not enough for any interview. Somebody just say, tell me what is OSI model? You say it's 7 layers and start quoting all this. This is garbage. So we should understand each layer, the functionalities, devices and protocol that functions in each layer. So this is where we're going to call it a day today. By God's grace, tomorrow we're going to move on to TCP/IP suite and some of the protocols, and then we'll talk about them. And then, before we jump to the lab, I want us to cover TCP/IP, and then we move to lab. We download some of the items we need to set up our own lab. So the rest will be story. So let me stop the recording from here. If anybody has a question, you should go ahead and ask.